Appreciate that. What we'd like you to do, or what we'd like you to come out of with this presentation is certainly the definition of off-ice, typical locations that this occurs, sources, and then also just some design and management considerations. I'll probably not emphasize the ones that Jeff had already talked about, but I will maybe talk a little bit more about ones that we look at for the core. Okay, so what is off-ice? Well, as Jeff actually set up for us nicely, so icing is a phenomena just in a general term where sheet-like masses of ice layers are formed on the ground surface or on a river or lake ice, and basically get successive flows that are frozen on top of the ice, and this can come from groundwater seepage, flow from a spring, or it can emerge from water in a river below a competent ice cover. And so for the purposes of this discussion, we're going to use the term off ice because that's pretty common for most hydraulic and hydrologists in North America. And what that is river ice that's formed from the freezing of successive flows of water over the top surface of previously formed ice. So this is ice forming on top of ice in a river environment. The off-ice formation is strongly associated with areas of Arctic and Nearctic regions. However, it can happen any place where you have the right conditions, and so that's something to consider. And then just to kind of reiterate here, we do have different forms of icing. The ground icing formed by seepage of groundwater, spring icing, which are successive layers formed by perennial spring discharge. And then in this case, our focus is the river icing formed by river discharge on top of ice cover. We are using the German term for this particular presentation, but just know that there are other terminology that might be out there in the literature or that you might see in reports. So globally, where does off-ice occur? Well, I mentioned it happens in Arctic or near Arctic regions. So this is including Canada, Alaska, Russia, China, and Mongolia. In fact, the largest off-ice formation in the world has been documented in Russia along the Moma River. And it's over 100,000 kilometers in area, in areas up to 7 meters thick. For Alaska, this identification of large off-ice formations has actually been done using satellite imagery, and essentially areas along the North Slope, ranging from the Colville River in the west to the Firth River in Canada in the east, and those are the larger formations. But again, it can happen anywhere where you have the right conditions, and so generally, you're going to be looking in areas with shallow depth of flow. We actually have kind of a limited understanding of, for off-ice, where and why it occurs. And so certainly limitations in the hydraulics and the feedback between the ice and the flow. Most rivers in cold regions do form ice covers in the winter, yet only certain ones form off ice. And so really what this breaks down to is there's two required conditions that have to be met for off ice to occur. And that is, you need an increase in water surface elevation stage as such. And basically the ice cover has to not respond to that increase in stage. So these are the two primary conditions that have to occur for off ice in areas. So now, when we look at the off ice initiation and water movement, and then we're going to talk a little bit about off ice blisters, and then year-to-year variability. So this will get in a little more detail as we go through here. So the initiation causes, at least what's been cited in the literature, they say similar things, but are slightly different. So Hardin in 77 basically said that there had to be flowing water and then some sort of barrier to that flow that pressurized it to force it to the surface of the ice cover. Hugh and Pollard took this definition and expanded upon it a little bit and said, well, there's actually a freeze up stage where you create a solid ice cover, and then an obstruction stage where you begin to pressurize the flow upstream of a certain location, and then you get the overflow stage, which is where the ice actually finds its way to the surface of the ice, or excuse me, the flow finds its way to the surface of the ice cover, and that's the formation of off ice. While I think those, conceptually are pretty straightforward, oftentimes we'll get questions about, okay, well, what type of channels can we expect this to happen? And, in wide rivers, this is not likely to happen because we actually expect the ice to move up and down with river stage. And so off ice formations are not routinely seen on wide rivers. Steep and small channels, there may be times where off ice formation occurs. More likely, we're going to see anchor ice formations, and then once they become snow covered, then it's just a solid ice cover and the water flowing underneath there, and it generally does not create an off ice condition. However, in narrow rivers, there can be a chance for off ice formation. This is because you can get strong and competent ice covers that freeze firmly to the channel banks and won't respond to any changes in stage. The most common location that is cited, at least in the literature, are braided rivers. And this is because the individual subchannels are small compared to the whole floodplain. And so you'll get ice adhering to the channel and not responding to any changes in flow, and certainly having off ice occurring. So here's some diagrams just to further illustrate this. You have a wide river and the ice sits on top of it, and we expect that ice to essentially respond to any changes in the stage. Now, when you have a river with off ice, while we don't have good data to give us exact measurements of how this might look, this image gives you a conceptualization of essentially the channel fills with ice, and then what happens is that the hydraulics of the stream flow are no longer dependent on the channel geometry. They're only dependent on the areas that are open still to flow that aren't iced completely. And so the interaction between these channels and the ice gets extremely complicated and is not well documented. And essentially what happens is when you have these constricted areas of conveyance, you're going to pressurize the water upstream and potentially force it to the surface through various locations, cracks, fissures, tree stems, etc. This particular delivery of the water to the surface location is highly stochastic, so it is challenging to predict. But this is something that has certainly been observed. So Hugh and Pollard, when they discussed this, they kind of wanted to step through how does flow get through fractures to the ice surface. And so these are the terms that they used. And I think for the most part, we still use them. So there's persistent hydraulic pressure, and that pressure is then released through tension fractures and other points of weakness in the ice cover. And therefore, there's a connection between the flowing water and the ice cover through what they term phreatic tubes. Phreatic tubes isn't something that we commonly use to describe this, but I think it conveys the idea of basically how pressurized flow might make it to the surface of the ice. Another location is along the stems of larger plants that might be encased already in off ice. And then certainly seepage around the edges of the riverbanks or edges of other ice bodies. Off-ice blisters, they're kind of a unique feature, and again, found in the Arctic and near Arctic. this is blisters are formed when any ice layer is pressurized, and that pressure causes deformation in the surface. And so what happens a lot is you'll get this pressurization of an ice layer, the blister forms, and then it actually loses connection with the water source. When you open up these blisters, often they can have water in them, but oftentimes they don't have any water, or maybe just a little bit of water, but mostly air. And so they are somewhat complicated and not necessarily easy to predict exactly what you'll find in there. And there are some rivers in Alaska where this has certainly been documented. And just to kind of reinforce both of these situations where off-ice blisters were documented were on braided portions of streams. There's quite a bit of year-to-year variability in off-ice formation. One 10-year study in Alaska found that there was a 500% variation in the maximum extents. And Slaughter in 1982 found that while off-ice can reoccur in the same locations year after year, it doesn't necessarily reoccur with the same magnitude, and nor does it necessarily occur every single year at one site. And Sloan in 1975 found that some smaller icings did not form annually, and then they definitely varied in extent and thickness from year to year. And finally, we can expect that if at a given location you see off-ice formation, it can be expected that it could reoccur in that same place in the future. So here is a study that was done a few years ago from our colleagues at Corel on Jarvis Creek. I was going to show you this video to demonstrate how this pressurization underneath the ice occurs. Let's see if this works. All right, I think that shows, gives you an illustration, and a colleague of ours, Steve Daly, narrating there. But yeah, this is a phenomenon that is well known, but not as well understood, at least in the river icing situation. Oops. So here at Jarvis Creek, here's a photo of discharge along the stems of larger plants. So this is in the overbank, and you can see where the ice basically used the trunks of these trees as a conduit to get to the surface, where the water used that as a conduit to get to the surface. Similar situation, not as large of vegetation, but same idea. The vegetation stems act as paths for the water to reach the surface. This is a little different here. So there was no identified single source of this water that was on top of the ice. And so best that the folks in the field could determine was this was all through tension fractures. So there was just hundreds or thousands of points where you had water that was coming through small cracks in the ice and was forming this off ice on Jarvis Creek. So this is kind of the situation where there isn't a single source but several of them. Here's another example, Engineer Creek near Fairbanks. And so first thing I just want to draw your attention to are the snow machine tracks that are in the foreground that are covered by ice. So you can see that off ice occurred after those tracks were made. And then you can just look at the overall amount of ice in this particular drain, in this particular channel. The lower left is a picture of Engineer Creek during fall freeze up, so you can get a sense of what the actual open water channel looks like versus what is iced up there in this picture. Here's Engineer Creek with, again, off ice occurring around large vegetation stems. And so in this case, it's using some of these trees and brush as the water's using that as a conduit to get to the surface. So the design considerations, Jeff talked about this in depth, and so I think he did a really good job, and I'll just touch on a couple of things here. The sheltering of streams from snowfall can actually result in deeper freezing of water. So as we've talked about for a better part of today, snow is a good insulator and will often slow down or even totally stop the ice growth. And so when you create a bridge or some other structure that actually catches the snowfall and therefore leaves the ice exposed to the atmosphere, you can get deeper freezing. So that may be a situation where you could promote the formation of off ice. Snow removal from roads may also contribute to this in a similar way. And then, of course, road cuts or where you intercept any potential water sources could be a potential issue for with off ice. The way to manage it, while there are definitely very specific management strategies, and Jeff did go through many of those, we kind of look at it a little broader. And so the first is you can do some monitoring if off ice is a concern, and some of the remote sensing platforms that are available, specifically the synthetic aperture radar, but Landsat and Sentinel-2 can be used. So this gives you helps give you an idea of the total extents potentially of the off icing problem. There are some instrumentation measures that could be useful in monitoring. And then also the vegetation. Again, as we've seen, vegetation creates that pathway for the water to reach the ice surface. So perhaps there's some sort of, I guess, management or consideration that you may have to consider if you have a source that is using that pathway to get there. Another management technique would be to do some actual modeling and determine what the possible consequences of the off ice. So in this case, you wouldn't be trying to mitigate off ice, but you'd be trying to understand what the consequences of it are for flood risk if you were to have water that was to flow down a completely ice-filled channel. And so there's some examples of this that have been done. Giovando et al. In 2006 and 2009 looked at some of the consequences of what the off ice formation may have for flooding. Mitigation can include looking at albedo changes on the ice, as Chandler had mentioned earlier. That's been mentioned in the literature. And then, of course, what we've seen today, some diversion channels, trying to divert it. Those potentially might be a way to mitigate it, depending on the exact situation. One of the considerations is, what does off ice look like in the future? And there's certainly very few studies that have addressed this, but the ones that have, essentially, the degradation of the permafrost may lead to decrease in the number of off ice fields, and that's been kind of confirmed with looking at the areas of Russia where they've had reduced off ice over the last 50 or 60 years. In northern Alaska, there was a study that evaluated 147 off ice fields, and essentially the results were they were getting smaller and then had earlier disappearance. But this is highly uncertain and very site specific. So I only put this out there so that people just have an idea of what's actually in the literature, which is not much. So just to summarize, so Aufeis is the surface flooding on top of ice cover, and the hydraulics of that are fairly there's fairly limited understanding, especially because there's such a strong interaction between ice and the water, and in this case, and the pressurization of that flow is a common phenomena that happens. And then along with that, you can get these off ice blisters, and you know, the year to year variability is quite a lot for off ice formation, which can make it difficult if you're trying to do any specific designs. There's pretty limited engineering options, but certainly, you know, we would encourage monitoring and modeling to be a good approach as a first step when doing any sort of engineering design. And then as far as climate impacts go, it's very uncertain at this point, but really the evidence is the off-ice fields are likely to be smaller. So that's the end of this particular topic, and I'll take any questions